Welcome back. In this tutorial, we are going to solve a design number container system. The container system must be able to do the following. It must insert a number at the given index in the system. It should return the smallest index for the given number in the system. And speak about the implementation of the containers class, it should have the empty constructor. It should have the change method. It fills the container at the given index with a given number. If there's already a number at that index, just replace it. This is the key moment, we'll discuss it later. And next we have the find method. It returns the smallest index for the given number, or -1, if there is no index that is filled by a number in the system. These types of questions are really interesting because they require having a good understanding of different data structures, and they teach you how to combine these different data structures, apply different methods so that your final solution is as efficient as possible. As we go through this tutorial, I will highlight the importance of applying different data structures so that our solution is as efficient as possible. Let's jump into the discussion part, the example 1. And the example given here is really interesting and it covers all the edge cases. Let's look at the input from the example 1. We have the following sequence of method calls. For the first time, find is called and change is called consequently 4 times, and next find, change, find are called. For the first time when find is called, the result is -1. This is true because the number container is empty at this time, and that's why we just return -1. And next several times we call change. This is how we fill our container system. And here I'm going to organize and organize the data in a way so that it will be easier for us to visualize and come up with the data structure that is the most suitable in this case. So let's insert our first value, our first number on the index 2. I'm going to organize data in this format. 10 number is our number, and this is the indexes with that value 10. For the first time, we insert 10 on the index 2. Next, 10 is inserted with index 1, 3, and 5. I'm just adding to this set of indexes. Okay, sorry, I missed 3 here. 2, 1, 3, and 5. This is this sequence of change method calls. And next, find 10 is called. As you can see, we have this data structure, or this is how we organize our indexes. And when find 10 is called, we should return the smallest index available from this set. And for this case, I'm going to use priority queue because priority queue gives us constant access to min or max value. And that's why this is really important to know different data structures and what kind of functions they provide and their efficiency. And that's why I'm just using priority queue. And this is a nice fit, this excellent choice for this case. And if you know some other data structures I could use in this case, please let me know in the comments. So let's go. And as you know, as you can see, or as you can tell me, that the minimum index is 1. And next, when we call this with these arguments, the following happens. We insert 20 on the index 1, but that index was already taken right here. Okay, let's go. Let's see what happens. In this case, I'm going to visualize or organize in a similar way. But when we call find 10, the next time the result must be 2, because 10 has already been moved to other group, because now 1 represents 20, not 10. And this is the hard part of this problem. And to map the actual relationship between the number and index, I have to use some additional map that will keep the actual relationship between number to index. Okay, for this storage of this data, I'm going to use map of int and priority queue, and additionally I will use map int and int. This will be our map to represent index to number representation, number, and this one will be the representation of number and all of its indexes. Okay, and what I'm going to illustrate next is, let's say that find 10 is called for the second time, and see Okay, first I'm going to draw the actual representation of index to number. 2 has the representation of 10, 1 has 20, 3 has representation of 10, and 5 has representation of 10. This is the index to number representation. Well, when 10 is called, for the first time when we insert it has this relationship, but it has been changed or updated in our second change call, and that's why when I get the Q by the number 10, I will use this Q, because this stores all our indexes that we inserted before, but the minimum value at this time will be 1, but I have to check that the value that we are looking for and the index that is returned by this Q this returns us, or this gives us 1. Since 1 has already a representation of 20, this data is no longer actual. This is fake, and that's why I'm just going to remove it. Remove, and next I'm going to use the next element from the queue, that is 2. The next minimum element in this queue will be 2, and that's why I'm just going to return 2. And we can check that the result will be 2, as you can see. And this is the whole idea behind this challenge, and next we are going to implement it. Let's start implementing our number container system. We have to implement two methods, change and find. First of all, I'm going to initialize our inner storage, and our storage is a representation of number to its indexes. It will be a number to index map indexes, and it's going to be mutable map of integer and priority queue as the storage for our indexes. And additionally, I'm going to use another map to store the actual relationship between the number and index. Index to number. It's going to be mutable map of integer and integer. Okay. Chain method is pretty simple. All we need to do is just to add the index to our number. Number to index, get or put. I'm using this method. I'll explain in a second. The key will be our number, and in case our queue is empty or null, I'm using get or put because since number to indexes, since map returns nullable queue, we cannot call any function on nullable object because it will throw a null pointer exception, and that's why in case of null, I'm just adding or initializing priority queue, and I'm calling on it add index. And this is how we are going to store our indexes by our key, that is our number. And next, I'm just using, or I'm just updating the relationship between index to number. Okay, that's it for our chain method, and we are going to implement find method. This is a bit harder compared to chain method. First of all, I'm going to get the queue by number, indexes number, and in case of priority queue is null, I'm just going to return -1, because if queue is empty or if queue is null, then it doesn't store anything. That's why we just return -1. And next, while queue is not empty, we get the first index. We get the first index and do the following check: index to number. We're getting the current number of this index. Well, let's call it value, and I'm going to check if the value returned by that index is equal to the number we are looking for. If this is true, then we can return index. And to explain what is going on right here, I'm going to show this case. When we added 4 indexes to 10, the minimum index is 1, but everything changes when we add this one. When we add this value, the representation of the 1 changes to 20, and that's why when we call find 10 for the second time, it returns 1, but its representation changes to 20, and that's why it's no longer 10. And since 20 is not equal to 10, we should remove this from this queue, and that's why I'm just calling here queue poll, and continue our iteration. Since there are more elements in the queue, we just return the second element, the second minimum value from the queue, and it will return us 2. And this is how we are going to implement, and in case queue is empty, we just return -1. And this is the end, or this is the whole implementation of this number container system. And let's copy and submit our solution right here. And I forgot to copy this import as well, because it will fail if we don't specify the import. As you can see, the approach is pretty efficient, and speaking about the complexity of this approach, since we have 2 methods, and we should consider both of them. Speaking about the memory of both methods, it will be on, because we are storing as many elements as the input size. And speaking about the time complexity, for change method, it will be log n. This is because the priority queue takes log n for adding elements, and for find method it will be constant time, because the map to retrieve a value from a map we use the constant time, and the priority queue as well. When we get the value from priority queue, it returns the value, the min or max value for constant time, and that's why when we add to constant time complexity, we get constant time. And this is the complexity analysis of this approach. This is the end of this tutorial. If you like this tutorial, you may like my other tutorials and my blog post on Medium and Substack. I will leave their links in the description section. See you in the next tutorials.